All right, Geometry Gurus, this is Mr. Moss. This is section 2.3. I know we probably will be covering this in class more or less, but I'm going to give this to you just for reference. And if you miss class, you can talk about this. So, section 2.1, we talked about inductive reasoning. And now we're talking about inductive reasoning. Now, deductive reasoning is more what we were talking about before, whereas where the clue game that we had mentioned and stuff like that too. Inductive reasoning had to do with more of a sequence of things and how that happens. So I'm just emphasizing that again. And deductive has to do with, and let's talk about that here. It says we're talking about the law of detachment. I'm going to zoom in a little bit more so we can read this and check it out. It says it's the process that detectives use to identify who is most likely responsible for a crime called deductive reasoning, okay? Unlike inductive reasoning, which uses pattern of examples, just like we talked about, so we're talking about patterns. Inductive, where's it? Yeah, inductive, patterns of examples of observations to make a conjecture. Now, deductive uses facts, rule, definitions, or even properties to reach logical conclusions from given statements, okay? So that's what we're talking about now. That's when we get into the clue game, or CSI stuff, or having to solve any of that kind of mysteries kind of thing. Okay, so here, let's look at our first example here. Determine whether each conclusion is based on inductive or deductive reasoning. So now we get to decide, is it based on a pattern, or is it based on facts? Okay, so every time Lauren has a healthy meal before her run, she is able to run farther than her sister who does not like healthy foods. Lauren has eaten a healthy meal, so she concludes that she will run farther than her sister. So, Lauren is basing her conclusion on a pattern of observations, so she is using inductive reasoning based on patterns, okay? Now let's look at the next one here. We haven't really seen it yet. I don't know if you can see the bottom part. If John is late making his car insurance payment, he will be assessed a late fee of $50. John's payment is late this month, so he concludes that he will be assessed a late fee of $50. So is this based on a fact, rules, or is this based on a pattern of scenarios? Okay, so John is basing this on facts provided to him by his insurance company, so he is using deductive reasoning, okay? So let's look at these couple other examples here that we have here. It says, do the same exact thing. It says, all the signature items on a restaurant's menu show are noted with a special symbol. Kevin orders a menu item that has this symbol next to it, so he concludes that the menu item that he has ordered is a signature item. Okay, so is this based on an observation, or is this based on facts and rules? Okay, how about the next one? Every time Raul goes to the restaurant on a Thursday, Cheese Supreme is the special. Raul goes to the restaurant on a Thursday, so he concludes that Cheese Supreme will be the special. It's like, you know, Subway, they have their sandwich of the day or something like that too. And they have that stuff. So is this based on deductive reasoning, or is this inductive reasoning? Okay. All right, we can talk about this in class too. All right. Okay, so now let's go down here. So this is what we have to talk about. Here's a couple of rules that are important to emphasize. It says, while one counterexample, only one counterexample, we talked about what counterexample is to prove that it's true, that it's false, or that it's not true, or whatever you want to call it, is enough to disprove a conjecture reached under an inductive reason. It is not logically correct or valid method of proving a conjecture. To prove a conjecture requires deductive reasoning. One of the valid forms of deductive reasoning is the law of detachment. Okay, so one of the valid forms of deductive reasoning is the law of detachment. So that's where we find something that's proven false in that scenario. Okay. All right, let's go to the next page now and see what we have here. And I'm going to move things around a little bit so we can do this a little bit better. Okay, so let's check out some new, key concepts here. I'm going to sneeze here. Excuse me. All right, so here we go again. So, key concepts of law of detachment, and this also is in your guided notes that we have that I handed out to you, and I'll bring that up here. It says if P then Q is true, then P is true, and then Q is true. Okay, this is the law of detachment, so both of them have to be true. So here's a scenario that we're talking about. Okay, if a car is out of gas, okay, then it will not start. So Sarah's car is out of gas. So what can we say is a valid conclusion? Sarah's car will not start. Okay? Does that make sense on that thing? So it's almost kind of like the law of, I'm trying to think here. I'm thinking on the top of the head here and I can't think of it. I'll think about it here in a minute, but we're talking about three scenarios, then that, you know, if one is true, then the second one's true, then it means the third one will be true if it's compared to that one. All right, so let's look at a couple examples here. As long as the facts are given are true, the conclusion reached uses deductive reasoning will also be true, okay? So this is kind of interesting stuff here. So, here we go. Determine whether each conclusion is valid based on the given information. If not, write invalid and then explain your reason. So the reasoning, really, what we're doing is giving a counter example. So here's a picture. And it says if two angles form a linear pair, hope you guys remember what a linear pair is. That means that two angles add up to be equal to 180 degrees and they share a common ray. Okay, so they have a common ray. Then their non-common sides are opposite rays. So this is a non-common side, and this is non, and that means they're opposite rays, which also means that they're a straight angle or a straight angle or a supplementary or a straight line. Okay, that means it says so angle AED, and AEB form a linear pair. So the conclusion is ED and EB are opposite rays. So we talked about that. Go in this direction. That means they're going completely opposite. So here we go. Identify the hypothesis and the conclusion Q of the conditional statement. So here's our thing. Two angles form a linear pair. That's what we have. So that's what we got out here. So we got this. Their non-common sides are opposite rays. Okay, so now we can write this as an if-then statement if we want to. It says right here, analyze the conclusion. So let's move that down here. And let's go with this. It says, the given statement AED and EB form a linear pair. Okay, that's the two angles we're talking about that we did in our scenario. Satisfies the hypothesis, which is true. Okay, so P is true. By the law of detachment, ED and EB are opposite rays, which matches Q. As we say, it is also true, so this is a valid conclusion. Okay? Here's another one. Micah goes to the beach. Okay? She will wear sunscreen. Micah is wearing sunscreen. So there's three statements here, so our concluding scenario. So here's our hypothesis. Micah goes to the beach. Okay, so we have Micah wears sunscreen. That is her conclusion. Okay, the given statement, let's read down here. It says the given statement, Micah is wearing sunscreen, satisfies the conclusion Q of the true conditional. However, knowing that a conditional statement and its conclusion are true does not make the hypothesis true. Micah could be wearing sunscreen because she is at the pool. The conclusion is invalid. Okay, just because she goes to the beach doesn't mean that you can go to lots of places. You could go to a sporting event, or you could go to an outdoor event of some kind, and it would be not necessarily be just because she's at the beach. That means she wears sunscreen, because you can wear sunscreen at a lot of different places. So that's why this would make this invalid. Okay, so let's check out this next one here. Okay, let's look at these scenarios and see if it's true or not. Okay, and then you can tell me, we can talk about it in class. If 3 points are non-collinear, again, non-collinear means that they don't all lie on the same line, then they can determine a plane. Okay, that is true. That's the definition. So point A, B, and C lie in plane G. I think that's what it shows, right? Okay, so here's our thing. The conclusion, points A, B, and C are non-collinear. Is that conclusion true? Okay, so we can talk about it in class. If a student turns in a permission slip, then the student can go on the field trip. Felipe turned in his permission slip. So here's the conclusion. Felipe can go on the field trip. Okay, so we can talk about that too. All right, any questions about this stuff? Hopefully it's making a little bit of sense on some things. Okay, all right, let's look at example number 3 now. Okay, I'm going to move this up a little bit here. Dealing with some good time. Okay, it says you can also use a Venn diagram to test the validity of a conclusion. Okay, so if you want to use a Venn diagram, I'm not much of a fan of it, but if it means and works out for you, that's good. Okay, here we go. Determine whether each conclusion is valid based on the given information. If not, write invalid. Explain the reasoning. That means that we get to use a counterexample. If a primate is an ape, then it does not have a tail. Coco is a primate who does not have a tail. Okay? Coco is an ape. So let's go back in. If a primate is an ape, then he does not have a tail. Okay? Coco is a primate, so that means who does not have a tail. So that means Coco must be it. So let's draw a Venn diagram. Okay, with tails and apes. Because we are only given that Coco does not have a tail, we can only conclude that Coco belongs outside the circle for the primates with tails. Okay? All right, does it make sense? So we got one with tails. These are all primates. There's apes that are primates, and then there's ones with tails, and these are ones usually it says without tails. So here we go. So this could put her in the area inside or outside the ape circle because it has both are true on that scenario. So does that necessarily mean that Coco could be a primate? The answer is that it is possible for Coco to be a primate without a tail and still not be an ape. Therefore, the conclusion is not valid. And I just gave a counterexample because you could sit there and say some kind of an ape, you can say a chimpanzee or something like that or whatever it may be. The Venn diagrams are a great way to visualize group and subgroups by representing the conditional as a Venn diagram. It's because it becomes clear that there are 2 possible subgroups and primates without tails in which Coco could be a member. Thus, we cannot definitively prove that Coco is an ape, and thus our answer is reasonable. Okay, so here's an example that we talked about too here. What about this one? If a figure is a square, then it is a polygon. So we've got an if-then statement here. That means figure A is a square. The conclusion is figure A is a polygon. Okay? So what do you guys think about that one? Is this one valid or invalid? And if it's invalid, what are we going to be doing about it? Okay? All right. So we're going to stop there for now for this part of it and explaining a couple things. I may come back with a couple other examples to show you as far as other scenarios.